Hey there, guys. Oh, is my microphone working? Hello. Yes, looks like it's working. How are you all this evening, and are you ready for a stream? Where we're going to try and fix a problem that was blowing stuff up. So, there might be stuff blowing up. Because, you know, if it's not fixed, it'll still blow up. And then we might be replacing a lot of RS-485 chips. But we'll see, I don't know, the URL for my chat overlay wasn't working anymore, so I replaced it. And I don't know if the heart is still there. Oh wait, the music's still loud. Something like that. So, oh, there's 39 people here already. How are you all doing tonight? And what are you having to drink? I'll share my drinks in a minute. Blame Google. Well, yes, they are YouTube, so... Probably the old URL I was using for years just didn't work anymore. It's okay. Just preparing a little connector here. Does peanut butter cup milkshake count as a drink? Holy shit, what the hell is that? Sounds like sugar death, but you know. Okay, let me finish this connector and then I can also have a drink. No, this isn't working. Yes. Uh-oh, my screen went blank. And it's back. Water van de kraan. Well, it's, you know, we have pretty good water here in the Netherlands. I guess it depends a little bit on which part you are, but... Now would be a good time to insert an ad. Well, no, I don't think so. No sugary drink, only beer. Oh, Draadstaal is here, nice. So, okay, this should be fixed. Oh, no, ripped it out. Well, I guess I could show you what I'm doing. Just preparing a little bit. I need some data connections to my powerboard sender 8 here. Because we'll be using that later in the stream. Nope, wait, it came out again. Get in there and stay in there. Pepsi Max. Eh. I basically only drink that when there's nothing else. Sorry. Oh, there you go. There! So now we have a brain board over here, which has 8 data outputs, and then it outputs that data to this sender 8 board, which takes in this data, and then there's all kinds of RS-485 chips there, and it sends it out over all these UTP connectors. Oh. But we'll play more of that later. That's not for now. Wine. Ooh. So let's see who was here first. No, it's still not a good time for an ad. I'm so excited to watch this stream today. I will be the first. I will be the first to order once available. Let's test this out and hope for the best. Nice. Yeah. Well, so there was a. Well, I'll talk about what the problem is and how I'm hoping to fix it later. Draadstaal was here second. Neil Young is here. We're going to smoke tonight. Well, if my fix works, we should not get smoke. If my fix doesn't work, however, we'll be blowing up plenty of shit. And replacing, and I don't know. New power diff will be good. Yes. Test. Well, that was me. Oh, music. Fat Daddy G8Z is here. It's probably pronounced differently, but, you know. Hello from Los Angeles by way of Mexico. Ooh, Okay. Time for ultra drink. Do we need an ultra? It's been a while, isn't it? Let me go back to the face. Oh. Power Diff-Power, yes. Do we still get the heart on screen? I don't think so. The new URL removed the heart. So for all the heart haters, it's gone now. Blame Google, yes. Topo Chico Saboris Blueberry with Hibiscus Extract. What? What the hell is that? Isn't needed. Yeah. No sugary drink, Pepsi Mac. I need that board. Hold on. It needs to work first. Well, I mean, work well first. Unsweetened soda water mixed with fresh fruit and berries. Just placed an order on a dig to go. Hopefully the WS2812B strip I ordered from AliExpress is decent. Or you could have ordered a kit and then it comes included. But yeah, normal strip should work. Hello. Dutch Makers here. Olaf from Ireland. Good evening all, says Chris. Smash the like button like the Hulk. Yes. You actually hated the heart, says Pius. Well, camp was divided. So let's do a poll. Did we hate the heart? Start poll. We have until the stream starts. I can't vote myself. That's too bad. I didn't hate the heart. So then, should we make Sprite zero sugar lime lemon whatever's ultra, or Fanta zero sugar lemon? It's all lemony today, isn't it? Yeah, ultra. I guess I should do another vote. No, I don't want to do another vote. First answer wins on my screen. Oh, Fanta wins. Dratsal won. Okay, so let's open up my label printer software here. No, away. Second for Fanta. Oh, it's got Sprite haters in the house. Hold on, my label software is... I don't know what it's doing. It's hanging. Oh, there we go. Okay. So we need to do it like these. And then make it ultra. Is it still hanging? Oh, it's still hanging. What the... What are you doing? You're not supposed to be doing... There we go. Okay. Wow. So stupid. Okay, let's get a nice font. Let's, I don't know. Yeah, this is a good ultra font. Okay. Let's print it in high quality. Go. Maybe my label printer is off. Maybe that's why it's complaining. No? Oh, it doesn't... I don't think it has the Wi-Fi. Uh-oh. Print is offline. Let me turn it off. Turn it back on again. This is the generic fix for printers that don't work. Turn it off and turn it on again. So let's hope it works. Come on, printer! Why can't it join the Wi-Fi? It's been in the same spot for like the past, I don't know, 6 years. So now it suddenly doesn't work. Label printer is already drunk. Yeah, let's wait for it to go to the Wi-Fi. I don't know. TS Production says, hi all, today my Dig Octa with Power 5 arrived. Well, now the wait for the LED strip begins. Nice! Have fun with the board. There are those that hate the heart and those that lie about it. Well, this is an anonymous poll, so hey, you can now heart your heart out. Did you change your headphones? No. Had these for a while. They're kind of, they're not doing great, because if you look at like the headband, you know, that's seen better times. The cups are still okay though, but yeah. I mean, yeah. At some point, it can't fall apart more than it already did, right? So then it's fine. Oh! Something joined the Wi-Fi. Oh, wow, this delayed Ultra. It's here, though. The Ultra is here. Hold on. Oh, hey, Unleashed got his dig quad a few days ago and got my LEDs hooked up at the weekend just gone. Thanks for making it easier. Happy to do it. So let's Ultra this up. You know. Maybe at some point I should release a Diff-Power Ultra, and it uses 1000 volts. I don't know. There, nice and even on the bottom here. Oh. So it uses 1000 volts and then 0.2 amps. That printed ultra fast. Yeah, once the printer decided to remember that it was a Wi-Fi printer. Before that, it was ultra slow. I feel this camera is slightly dark. Don't we feel the same? So let me push a little button here. There. Now it's slightly less dark. Good. I think. When's the next PC build? I don't know. Once the new Ryzen comes out, I think I'll be building a few new PCs. Not just for myself, but also for some other people. But yeah, we'll have to see. Nice being time on your printer. Your Quinled Diff Solo receiver and RS485 outboards don't transmit power across Cat5. Assume that that's what you'll be demonstrating today. Yes, so we have Diff Solo, that's already been released. I'm working on Diff Advanced, that is a more advanced version, but still doesn't transfer power, but you can do 4 signals over a single cable and all kinds of other stuff. And after that, we'll have Diff-Power, and that's what we're working on today. And that indeed sends data and the signal. So where do I put in an order for a new PC? Well, if I have time, I like designing stuff for friends and then building it, so... Or like for my dad, or things like that. Stubbs Christmas says, "Hey Quinn, have a great stream." Thank you. You too. You're here. I mean, 1 minute and then we'll find out if the heart should return or not. So now it's a bit bright. Damn it. It's always something, isn't it? Okay, let me take it back. No, it's more bright. There. That looks better. That looks better. Okay. There. We'll keep it like that. You want pink standoffs. Oh. That would probably be a custom order. Make it lots more expensive. You got used to the heart. Okay, it's 21:15. So I'm ending the poll. End poll. Do we get it? Okay. 59% says yes, we hated the heart. 40% says no, we did not hate the heart. So with 37 votes, although there's 67 people here, I guess the heart is not making a return. Damn it. I kind of like the heart. I thought it was funny. So, what are we doing today? I forgot to prepare something. Hold on, let me get a box. I need to get a box. Is the box here? The box is here. I don't need to get the box. Hold on. So for Power Diff, we have, again, like the other diff boards, a sender and a receiver board. For the sender, we have 2 choices that I'm developing, and one of those is the Sender 1. Now, this is a board we've blown up previously, and we'll probably do again today, but we're not going to talk about that. This takes in 48 to 55 volts, and makes it 5 volt for the output of the data signal, and also for an ESP or DIG board you can attach to feed it the data. The problem is, though, with the current design is that the output boards are always providing power. So, as I was saying, I got sidetracked. This is the sender 1, so it has one output for power and data. So you can hook up one receiver board. We'll look at the receivers in a minute. Then, what I'm also working on is the sender 8. As you can see here, power board sender 8. This takes in 8 data signals. I need to get that drink. It uses a Dig-Octa brain board for that to provide those data signals, and it can also power it, etc. So you can have 48 to 55 volt in. It has 8 RS485 chips and then also 8 U2P outputs, so you can have 8 times power plus data per output, or you can give it 4 data channels and then you have 4 channels left to do power injection or things like that, right? So that's what we currently have. I'm not sure there will be more sender boards, maybe not, but a sender 1 if you just need to do one thing, and a sender 8 if you want to build your whole house around it, right? So then, once that data and power is on your U2P cable, it needs to be received somewhere. So we have receiver boards, and they take in the RJ45 U2P cable and transform that power, because it's 55 volt minus whatever was lost on the cable, take it into the board, send it to this giant buck converter here, and then send it back to the board, and then you get 3 positive, 3 negative, and a data output, and it's nicely power distributed and fusing, and there's a level shifter on there, and a data resistor selector, etc., etc. Right? And there's broken fuse LED indicators, so it's basically part of the Dig-Octa lineup in regards to features. There's nice big terminals and things like that. Except then it also, it all travels over USB cables. But if you don't need like 15 or 20 amps of 5 volt, this might be a bit big. So this is the receiver large. The naming still isn't correct on here, but on newer versions it is. We also have the receiver medium. This was called the mini before, but I've renamed it to medium because we'll also have mini and nano versions in phase 2. Phase 2 is later. We'll release this first, and then we'll work on even smaller receivers and things like that. So this is a lot smaller package, as you can see. I mean, this is a lot smaller, so it's easier to put somewhere where you want to receive it. Again, it has an input port, then it goes to a buck converter. It has fusing and things like that on board, large capacitor, level shifters, broken fuse indicators, etc., etc. And then you output that to an LED strip. Well, so far, all of that has been working great, except when you plug it in. When you plug it in, it instantly starts drawing power. And the problem is the RJ45 connector, when you're mating it and you have several pins that have 55 volt on there, you might get some short circuits on there. Now, if you take a look at the board, each individual pair that is sending power is fused and in that way also partially limited. Still, if that crosses over, that wouldn't be good. But at least power-wise, even if ground and 55 volt would cross, one of the fuses would activate, and that would be safe. That is not a big problem. But it's not ideal, but it's not a big problem. Nothing will die. What is a problem, though, is that it can also cross over to the pair that's carrying the data, and that will instantly kill your RS485 chip, either on the sender or on the receiver. So I was thinking, like, okay, so, no, these are not very noisy that I have noticed, no. So I was thinking, okay, how do we prevent that? And I took a look at PUE and how it does that, because, PUE is out there and it works, and, you don't always have to think of new solutions. And I was thinking, okay, when you have PUE, and we also saw this in our PUE testing stream, if you apply the RJ45 connector to the receiving board, it doesn't instantly activate power. It activates a little bit of logic, and then, once the connector is fully mated, it then applies power. I was thinking, okay, well, we can do that. So do I need to implement that on the sending or on the receiving side? And I was like, no, we need to do that on the receiving side because it needs power to boot up. And then it can activate the main power to the LEDs and the big capacitors and things like that later. Well, that's exactly what I designed. I hope. Because that's not been tested yet, right? So this is the current version, I think, or one of the current versions. And because I didn't want to build all the boards on the stream, I decided to, well, get somebody else to build the boards. So here are 5 mostly built boards of a new revision that implement a dual stage power delay circuit, as I'll call it. There is a 5 timer chip on there that then slowly, after like half a second or so, slowly charges a MOSFET gate that slowly rises, so still power isn't applied instantly, but it slowly rises to then provide full power in the end. And I'm hoping with that it'll prevent the issues of hot plugging, because that's the problem. If you would turn off the system, plug everything in, turn it on, excellent, no problem, works every time. But if you hot plug the UTP connector 1 in 10 times, and especially if you're wiggling with it and stuff like that, it'll blow something up that it shouldn't. So I was like, okay, then let's just delay the power. So I have a very minimal power circuit that gets turned on first. That powers the timer and things like that. And then once that is done, it'll turn on the rest of the circuit and the LEDs and the buck converter and things like that, get power. And then hopefully, well, that solves that problem. So this is really the first version of this circuit. I have not tested it. This has gone from the brain to the schematics editor to the PCB. And now we're here. As you can see, the PCB also grew a little bit. You have to forgive me that I didn't use red because that would have caused extra delay. But basically the idea is the same. We still have the RJ45 connector here and the buck converter goes here. But I made the PCB a little bit bigger so that once the buck converter is on there like so, you can still see the LEDs and the screw terminals now. Well, the capacitor too, but you know. So that sticks out, so you can still mate or connect and disconnect LEDs even with the buck converter on there, in theory, right? And I also made it so that the labels for which connector does is actually in front of the screw terminal instead of behind it. So, yeah. So what we need to do first today is we're going to build up one of these boards and then test it a little bit. And if it works, I will be building a few more, but I'm not sure if we'll be doing that on stream or not. Let's see how far we get. Because I need, 8 at least to test the big receiver board to see if that actually works or not, right? So I need enough receivers in the end. But let's work on this board first, because it still needs a few things that I didn't get pre-assembled. If you take a closer look at it, maybe the lights aren't at full power. There, that's better. If you take a closer look at it, you see that there's some regulators missing here, but all the other surface mount components should be there. So we need to add these regulators, and then we need to add all the through-hole components, and then we should be done, and we should be able to test it. No, so although these say 36 to 48 volts, if you get the correct versions, they will do 30 volts minimum to 60 volts maximum in. So I know it says 36 to 48, but this will do up to 60 volts. And since we're sending 55 volts out, it depends on the losses on the UTP cable, what actually arrives. So if that's 55, 50, 48, 42, 39, whatever, makes it to the end, the buck converter will take that in and make 5 volt out of it. And the same with this guy. This also says 3648, and it'll do up to 60 volt. But I have some others here. This one, for instance, yeah, this one. These are the 60 volt input versions, and those will basically do the same. They'll do 30 volts to 60 volts in. So that's perfect for our use case. All right. So we need to get these little regulators here, and I think I'm going to try and do that with my iron. No problem, Dan. That's a good question. Yeah, but we're basically using the loss or the expected loss on the UTP cable, but instead of powering whatever is behind the UTP cable directly, we're always going to have a variable loss, even if there's like 100 milliamp or 2 amps being used. The voltage will vary, especially if you're using a 50 or 100 meter cable, right? So we don't link a static voltage device like 5 or 12 or 24 volt directly. We run that to a buck converter, so even if the voltage fluctuates between 42 and 49 volts input, the output will always be a 5, 12 or 24 volt stable. I need to get this this LDO. Oh, it might actually be in my bin here. I'm not sure. I need these later. Or maybe I you know, cleaned it up and it's in the right bin. Let's see. What? No. LDO. I'm going to try and think I remember which one it should be. I think it's this one. But I'm going to double check it first, just to be sure. Later there, Dutch Maker. Thanks for joining for a little bit. So let me double check if that is the right LDO. Power diff, receiver medium. Oh no, uh-oh. I need KiCad 8. I don't have KiCad 8 on here. Okay, I need to download KiCad 8 real quick, hold on. Gives me time to drink my ultra drink. Are we expecting smoke today? Yes, if my solution is bad, we'll have smoke today. Oh, they almost made it to the KiCad 2024 fund drive. They have $99,871 donated of a $100,000 total. Nice. I donated X amount, let's say that, and I got a free t-shirt. So, wow, that's slow. Okay. 5 minutes left? What? Okay, let's download it from somewhere else. Okay, 30 seconds left. That's better. Fanta outlet. Yeah, it's Fanta Zero Sugar Lemon Ultra. Ultra. Look at the Ultra. Okay. Download completed. Just need to verify real quick. It would be stupid if we put the wrong LDO on there. Then at least we get smoke. I mean, that I get. Oh, right. Okay. There's too many screens. Yes. It has 1 more horsepower now. Exactly, Perry. Oh, it's a kitty. Hello, kitty. Hey. And we're not going to do head scratches now. No, no. Kitty interrupts the stream again. He's like, hey, we did this last time. It turned out well. Let's try it again. Oh, where are you going? Don't go under my chair. Wow. Can you hear him? Let's see. Okay, yeah. Start with default. No. Okay. Okay, let's see if I can open my schematic now. Kitty. Oh, I need to click so many buttons. Okay. DS8603 5V. Yeah, good. Okay, I got the right one on the first try. Nice. Quincat. No, yeah, we could have called him that, but we called him Kitty. So we're gonna try without the microscope first. And, who knows, maybe then later we'll try... Wait. Okay. We'll try with the microscope, or at least verify with the microscope, but... We shall see if I can do this job without it. So let me prepare. I need my fume extractor. And I guess I could also do this with paste instead of the soldering iron, but we're going to try the soldering iron first. There's only a few pins, and I'll flux it up, and then it should be fine. So, let's go that one. This one, I think. Yep. I actually ordered some new tips, but I'm not sure they've arrived yet. Okay, we need tweezers. Hey, I'm a sextoid. So, one needs to go here. There. Nope. And one goes here. Now, we don't actually need to look at this in native resolution, do we? Whoop. There! Now we're in like zoomed in resolution, but it doesn't really matter. At least it's clear. Okay, we don't need this tip. This tip might be a bit big. It's as big as the component itself. Let's try this one. I know I have some tips that aren't working anymore, but I ordered some new ones. Okay. Fume extractor on. So I think I'm just going to tin one of the pads. and then see if I can stick it down there. So these two are also missing, these over here, but that's correct, we don't need those. So I'm just going to tin this pad here. There. And we're going to try and align this. Nope. Oh no, it jumped. How's that? That'll work. Okay, let's do the other one too. And then we're going to flux it up, and then we're going to try and do the other pads. Doesn't want to take tin here. I enabled a new feature on my YouTube today, and that is that my front page will show community clips. So in theory you should now be able to make clips during the live stream, and then it will show up on the on my front page. It's an interesting feature. There, that should also be pretty well aligned, I'd say. Okay, let's get some flux. I guess we could use the flux pen. My soldering temp is 380 right now. Hovering on the clip button from Magic Smoke. No, there actually shouldn't be via in pads. I think that is just reflection. They're not vias in pads, because I normally wouldn't do that unless I don't have another choice. So if they're stuck down, I should be able to just do this, and they shouldn't move. There. Come on, camera, what are you doing? Okay. And then let's see if we can do the other pads without... For some reason this tip doesn't like taking in solder. That's a bit much. I don't like this tip. I'm going to change it for another one. But I hope that one isn't broken. Yeah, this is the broken one. Damn it. It doesn't heat up anymore. Well, I guess we'll try this one. So it's also not heating up anymore. Okay. I guess we'll go back to this one. Okay. Yeah, that's why I ordered new tips, because, you know, if they're not heating up anymore, that's not going to work. So let's try and do these. These should be easier. don't like these tips because they don't do well with the heat. The solder really isn't flowing basically. So okay, I'm gonna try another one, larger one, maybe this one. Yeah, I could do a via in-pad to save space, but generally I don't, unless I really can't prevent it. Okay, so let's see if this one does better. Oh yes, look at that. Much better. Okay, good. So I intentionally made a mess of that, but in theory we should be able to flux that up. And hopefully we can then easily clean it off. Maybe not today. Why don't you want to work? Yeah, I need some better flux. I have some different flux, but I thought I'd use this pen here. It's not doing the job though. Let me get my other flux. Zero flux given, yeah. I can use some desolder wire too. I'm gonna try with some more flux, and if that doesn't work, we'll use some braid. We're just gonna drown it in flux, and then, you know. Okay. There. That's at least fluxed up. I think that instantly fixed it. But it's a bit hard to see now, so let me try and dap that off. We're gonna make a giant mess of this board like this. I should have just gone with paste. It's okay. Didn't think this would be this hard. But for some reason it doesn't want to cooperate. Get off of it. Oh, I got it. There. That got it, I think. Finally. Jeez. And let me verify real quick. Yeah. That'll do. So now let's try to do the other one with the flux immediately. I don't like this soldering tip. We're going back to the original. No, not this one, not this one. This one. This tip is way too big, but I know it, at least I know it holds a good thermal mass. See, those are easy now. Okay, let me double check. Yeah, there's a bit much flux on there, but other than that, they should be fine. Yep. Good. Okay, let's do the rest. Should be easier than this. I'll leave the flux around just to be sure. Okay. Let's see what we need. We need a capacitor. And then we need an RJ45 socket, a 4-pin, a 3-pin, and a fuse. Okay. Let me see if I happen to have some in these boxes. Maybe. Nope. Okay, then they should be in this box. Yes, that's one. Okay, that's two. Oh, they're over here. Okay. Okay, well, whatever. Okay, let's use those. Various connectors. Okay, and then we need some PVC through hole. good. So let's get enough for this board and then we can start testing it. So I'm using 5 amp PTCs on here, these guys, as fuses. I'm actually debating of maybe changing that back to pluggable fuse style. I haven't fully decided yet. We're going to be doing more tests in the coming months or the coming time. But I've had some issues with these PTCs recently. I'll probably share that as the secret today. One more vote for I Hate It the Heart. Aw. Poor little heart. Okay. Okay. That is fine, that is fine. So let's plug it in, see what's highest. We got these. Oh, we need to join these two together. In theory that works. There. Okay. We have the capacitor. So the capacitor is higher than the screw terminal, so that goes on later. And then we have the PTC, that's probably highest, yep. And then we have the RJ45 socket. That's actually lower than the screw terminals, but since it snaps in, we can leave that there. And we will do the screw terminals first, and then RJ45, and then do the others. I haven't played too much with LED effects myself, but I've heard a lot of others about it, and I looked at it once. And yeah, you can do some cool stuff with that. So let's, oh wait, you can't see. Let's do one for each. And then see how straight they are, but this should be fine. A little bit. There. Yep. One moment. I don't think I still have a bridge, but I'll check with the microscope just to be sure. There. Those look pretty good. Let's do the fuse or the capacitor first. That's straight enough, let's say. I like filling the hole with solder, just, you know, there. That's pretty good. So then we only have the PTC left. And I'm intentionally going to solder that slightly while it's up, so I need to plug that in, and I want to raise the legs a little bit and then bend them so that it's not fully seated, basically, so that I can easily bend it over. Let's see, I'm going to do this. Well, I guess I can bend it now. So I've designed it so that it can go fairly flat inside of those. Let's bend it a little bit this way. There. That should be fine. But then how do I solder it? It doesn't move. I guess I could get a little tape, but I'll just angle it for now. Tack one on. I know you can't see. Let's verify that it's in the correct spot. Yes, it is. So it's not touching anything, but it's neatly tucked away there. Okay. No magic smoke yet, Monty, just soldering fumes. Okay, so that's fine. Now it's nicely tucked away. Ow, ow, ow. Okay, still hot. Let's snip off these legs. Good. Okay, so let me zoom that out again. Nope, wrong one. There. Good. So this is what the current prototype looks like. It has some extra circuitry underneath there. So there's a 5x5 timer, and there's a MOSFET and all kinds of capacitors and things like that. This is the PTC fuse. Although, as I said, I'm not sure I'm keeping it, but we'll see. But currently, you can tuck it out of the way nicely. It doesn't touch the board or any of the pins. And, you know, it can sit there because the buck converter goes on top of it. But as long as it's not touching, that's fine. I believe we soldered all the pins. Yeah, cool. Okay, so let me put my flux away. And the reason I'm doing this on stream, we'll first test if it works. And if it works, we're going to try and break it intentionally. And I know you guys like that. Oh, wait. Oh, we were still going to inspect what we soldered with my microscope, right? Well, let's do that, just to be sure, because otherwise we'll get erroneous results. We'll think it's not working because of reason A, and it might not be working because of... Sorry, reason B. No, I still need to look for them. I went on a hunt recently and probably got distracted, so it didn't finish. So let's get the microscope. And plug in this. There. Of course, I'm stupid, because now if there's an error, I probably almost can't reach it anymore. But that's how we roll. Okay. Let's turn it on. There we go. Oh, we're immediately in the right spot. So let's zoom in. So there's some black sud there, but that's just burnt flux and stuff. I'd say I'd say these legs are all pretty pretty solid. Yeah, that's on there. Yep. Okay, let's check the other one. Yeah, that'll work. No problem. Oh, the resistor is still there? Yeah. I guess we can check what the PCB company did in regards to soldering work. So there's our 5 for 5 timer. Oh, looks pretty good. There's our MOSFET. You can clearly see the gate pin over here. This is our input, and this is our output, our switched output. That all looks great. This is our RS485 chip. Where are our LEDs? Oh, over here. Right. These are the LEDs for the incoming pairs. So it says it right here. Come on. Pair online. Good. And then we have our buck converter connection. So 55 volt buck input, ground, buck output. That goes to this fuse here. Yep. That all looks great. Okay. Let's put this away. Now, as I said, this is a very new circuit for me, with new chips and things like that. Not used it before. So this could very well do nothing. Just not come online. That's it. The end. Well, then I guess we'll try and troubleshoot a little bit. So, what are we going to do? We're going to take this. Okay, let's put my soldering iron away. I need those new tips because these aren't great anymore. They're a few years old now, so that's okay. As you could see with the good tip, it went very easily. What do we need? We need bench power supply. But we need bench power supply on sender 1. This guy. Because we'll hook it up to here. Wait. Sorry. There. Now you can also see. So we'll hook up bench power supply to here, and then we can apply 55 volts. We should be able to do a little trick here, where we can have ground in both terminals. I'll get the manual screwdriver for that. Don't like flathead screw terminals, but those are what I have like for prototyping. When I do a big batch, I custom order screw terminals, and then I pay extra to have the Phillips terminals there because flathead just sucks. Okay, so now we're going to get 55 volt in from the bench power supply. That's going to be made into 5 volt for the onboard electronics and the RS485, and output to a DIC quad. So this can actually feed the board. Now this is a mangled version that's on my desk, but at least one of the outputs should still be good. Okay. Looks like output 4. Okay. It came from the PCB house with no magic smoke installed. Well, let's hope so. Not on the power output, on the data output. Now, what's important when you have something feeding your board that is going to take in data, be it an LED strip or something else? Can anyone tell me what's important to make sure you have in regards to power connections? Are you all just watching, all mesmerized? Groins! What? It needs to have a common ground. There you go, Monty. That is correct. But, yep, Mr. Revenant corrected his groins to ground. Very good. But since we're feeding from here, and this board is taking in the 55 volt, making it 5 volt, and then outputting it to the DIC quad, we already have a shared ground with the DIC quad. So we don't have to run a data and a ground cable. We can just run a data cable, and the ground's bridged here, so that should be fine. You hate AutoCarrot? Yes. Yes, I do too. Oh, that's funny. Okay. I think that was not by accident, but it's still funny. Okay, so now we need a UTP cable going from here to here, and then we'll see what happens. I'm really kind of scared because I don't know. Pardon me. UTP. Hold on. Do I have a short UTP cable here? Because that makes it worse. Yes, I do. We're going to use a really, a Sumsy. Oh. Smoke time, just in time, eh, Philip? Yes, we're going to use a really short UTP cable, because then we know the input voltage is the highest possible. And we're not doing stage testing on a live stream. Come on. Okay, well, we're going to do it first without the LED strip installed. And without the buck converter installed. And then we'll add the buck converter, and then we'll add the LED strip. 5 of 96 likes? What do you mean? Are you guys not liking the live stream? If so, do tell me. I mean, maybe I can change something. Now I'm feeling all insecure. I'm not. It's okay. You're allowed to not like the live stream. That's fine. Oh, we got 30 likes now. Oh, thanks, guys. Okay, UTP cable here. UTP cable here. Now this should, in theory, work. In theory. Okay, let's turn on the bench power supply. No output yet, but let's put it all in view of everyone. Kind of looks like a bomb right now, doesn't it? Okay, V set 55. I set. Okay, I'm gonna go conservative. Half an amp. Okay. Still, half an amp at 55 volt is like 25, 27 watts. I mean, it's not nothing. Okay, I'm gonna lean back because, you know, it could explode. Okay, we'll zoom in a little bit. There. Now, what in theory should happen? These lights should come on. That is the output pairs that they're, or input pairs that they're receiving power. And over here are 3 lights. And one should come on, and then after a little bit, another one should come on, and then the third one probably doesn't, because we don't have the buck converter on there yet, right? We got some really good fire extinguisher. So we got this can of, well, it says it right here, Fire Stop. The only problem is, okay, I need to get a new can. Hold on. The only problem is, what does it say there? Oh no, that's date of production. That's not date of production. How long can you keep such a can? Does it say? No, it's date of production, so it's not expiry date. You can't refill it. Okay. To be used with all fires in-house. We're in a house. Good. It's been used. No, it's still sealed. Oh, when there's a fire, you first need to shake it, then unseal it, then uncap it, then spray. So there's a fire going. You're like, holy shit, there's fire. You got to start shaking this thing. How long do you shake it? A minute? Okay. Do not power up till I come back. When are you coming back? It self-destructs when it expires. Oh, that's good. So when are you coming back, Ray? Ray, are you gone? Now I can't power up. What's this about? Are you going caca, Ray? I mean, where are you going right at this minute? That is so important that you had to leave. This must have been one important duty. Haha. Okay, sorry. I'll stop with the bad jokes. In 2 mins. He's AFK. No, now we can't start. Can you walk through the components and the roles again? Okay, well, sure. Hold on. Until Ray's back, because, you know, we gotta wait. So we have 55 volts coming in over here. Okay? This board takes the 55 volts and sends it out through this UTP connector with some protections and capacitors and things like that. This board makes 5 volt also for the onboard RS-485 chip that's been replaced 6 times already. Don't ask. And then sends it also to this DIG quad. This DIG quad then boots and sends a data signal again to this board, which then sends it out to the UTP cable to this board, to which you then connect your LED strip. But this can be 50 or 100 meters away, and it carries power and data. Are you back, Ray? This Ray is taking a while, huh? I'm just nervous to turn it on. We're using 3 pairs for power and 1 pair for data. There is a document in the Quinled.info diff section which details the pinout for Diff Solo, Diff Advanced, and Diff-Power. Is he back? Oh, nature call. Okay, Ray's back. We can now start. Okay, hold on. Hold on. We have about 100 people here. Well, let's see what happens. Go. Oh, okay. That worked perfectly. Did you see the delay in it coming on? I did. So let's try that again. Let's try that again. Let's unpower it. This needs to bleed a little bit. We power it up. Bam. So first this one turns on. That is board power 5 volt. Good. And then buck power in comes on. But it came on slightly delayed. So let's do it again. Oh! Look at that. Awesome. So then let's test it by plugging it. Oh. Now it came back immediately. That's not good. Why? Let's wait a little bit. Okay, let's plug it in. Why is it coming on immediately? That's not supposed to happen. So if I turn off power, turn on power, it works. No, RC circuit. I actually want it to be off instead of just slow. But there's actually a second stage, which is an RC circuit on the gate for the MOSFET. So when I power it on, it works correctly. But when I unplug it, it doesn't. I don't understand. Why? Doing it? Okay, we need the multimeter. Ray's gonna... What? No. We're not waiting again, Ray. Come on. Okay, let's boot the multimeter. There is also an RC circuit on the gate. But there is a issue if you have the RC circuit and you plug and unplug it too quickly, it wouldn't be discharged yet, so there's a problem there. The device is not connected. Okay, why not? Dead. Okay. Connect. Play. Okay, whatever. Actually, I thought the timer circuit would be slower, but it's reacting pretty quickly. So let's measure it. Currently, we have a raise back again. Nice. So, hold on. Let me see if I can do it in a way that it's visible. Yeah. We don't need that one. Currently, we have 55 volt. Let's turn it off. Okay. Let's set the multimeter to fast. Oh, I need to exit remote mode. Jesus. Can we do that here too? There, we set it to middle speed at 60 volt. That should help. So let's turn it on. That's not a very slow gate, is it? Well, at least in voltage. I guess amperage could still be slow. So let's do that again. You see the LED come on, and then slowly after... Or I wanted more delay. There's not enough delay there. I guess I need to play with the capacitors a little bit and the resistor. But, you know, there's something. That's good. My on-screen chat is frozen. Oh. There. Fixed it. compare it on the output side? How do you mean? I actually want to test it. Maybe I can just insert these. Like so. And I want to test it while plugging it in. If there's actually a delay there or not. Yeah, I'd say there is, but there's not enough delay. I wanted more delay. Yeah, might need to experiment with some different resistors there. But let's add a buck converter. And then let's see what it does with the actual power output. Oh, the heart is back? That's just funny. I have no idea how that heart came back. I had no idea how it went away from the first place. So, okay. Okay, so let's get this screwed in. I can connect the scope to see the timing, but I like to do real life testing on the live stream. Seemingly not, Draadstal. Either a bigger cap or a larger resistor. Or I did it completely wrong, that's possible too. But there's some delay. But I want it to be half a second to a second. So. Okay. Let's get these standoffs off. Or rather, let's not take these standoffs off yet. So we can measure voltage on here too. Okay. Wait. Go away. Okay. Okay, so let's apply power. Yeah, that gets 5 volt pretty quickly. So, power. Yeah, this is not using PUE or anything like that. This is basically just using U2P cables and RJ45 connectors. Haters can't kill the heart. Thanks for the donation there, Scott. That's appreciated. Nice. So let's get some basic 5 volt strip. And we should be able to connect that over here. So I like, I've been trying to do this, but these are not the exact right screw terminals. I've been trying to label in front of the terminal what it actually does. Because then if you're screwing it in, you can just be like, oh, I need VCC. Okay, VCC is... Oh, I need to open these. Yes, there should be, Gary. But the first time is just as fast as the 7th time, so I don't think that is the issue currently. So let's first see if this works. So if we turn this on... Oh, that didn't work. Wait, this was 5 volt out, right? Yes, 5 volt out. Yes, 5 volt, good. This is a 5 volt strip? Yes. Okay, so now it might be having an issue, because there was no load, of course, so the slowly raising gate wouldn't have any problem, because it doesn't really matter how massively the gate was raised or not. There was no load whatsoever on there. So now it's probably slowly rising. Yeah, there we go. Oh, but now, okay, so now the buck converter can't start. Oh, wait, I know why. I'm still limiting at 0.5 amp. Let's limit at 2 amps. See if that changes anything. So let's see on the input side. Power. Oh, it's still not doing it. Interesting. But it's saying it's CC limit. It can't be CC limited, can it? So, why is it not booting? Yeah, we should check if anything is getting warm. That's a good point. Oh. We'll just leave it flipping like this while we check that. Oh yeah, something's warm. Okay. Something is 100 degrees. That's not good. So it looks like the MOSFET is very warm. Interesting. So let's try that again. Oh, wait, it worked? It says it's online. Nothing's getting hot. These resistors get hot, but that's pretty normal. Okay, but then why don't we have any output? So let's check. We have 54 volts on the input. We have 5 volts on the output. We have 5 volts on the output side, even with this ground. Good. Oh. Huh? Our data signal is 5 volt. That can't be good. We likely blew up something. Interesting. So let's see over here. Still okay, nothing too hot. Let's see over here what our data signal is. So our data signal is 0 volts on the incoming board, but that's, you know, that's okay. The 5 volts on the output board is definitely wrong. So we need to check input here. Power. No, well, I can disconnect it, but I think we're still having 5 volt on the output. Yep. So the LEDs are disconnected. But what did we blow up? I think we blew up the RS485 chip, but I'm not sure if it's on this side or on the other side. That's still correct. We're getting 5 volt on our RS485 data out. Well, okay, we are getting a normal data signal on the data input on the sender board. So I think one of the RS485 chips just died because of the flipping. But why did the flipping happen? Trying to analyze here. It could be because I limited my bench power supply, but at one point it was at 2 amps. That's like 100 watts. That should be plenty. Try some 5 volt LEDs. We just did. So this is active, I would say. Yes. Does the delay still work? Maybe not. Something random, because it's an average voltage, but if it's steady 5 volt, you're at least not sending out a data signal. But something weird is going on, because now the delay doesn't work at all. So there might be more stuff blown up. Yeah. Well, we're not sure it was fine. I mean, this is not doing anything. This might be a back to the drawing board type of deal. Because if we turn it off, let's wait for it to drain a little bit. This is the output, so. So let's, yeah, there's no delay there. Sure, I'll set it to 0.5 amps again. Maybe the JST connector is bad. Well, the output fuse isn't triggered. So, I don't think so. Well, I can disconnect it. Let's disconnect it. I don't know. But I think stuff is just blown up. Okay, so. Let's measure here. Come on. Yeah. On. 0 delay. Because of the layout of the board, I could make data in the middle, but I never understood why it was. Because if you're using 12 volt or 24 volt, and your data pin is next to your positive voltage pin, why would you do that? Because then if you accidentally short it, your LED is dead. And now if you do that, it's ground. It's okay. Well, there's 3 5-volt, no, actually 4 5-volt supplies on this board currently. Let me disconnect the buck converter. Okay, so now we don't have a buck converter. Well, the buck converter LED glows dimly. I'm not sure why that happens. I thought about putting a pull down on there, but I never did, so. Sorry. Yeah, for some reason the delay thing is just gone kaputski. Did our 555 timer chip always look like this? Hold on. Yeah, it did. Okay. Okay, we can inspect the board to see if we blew something up. I'm not going to do very intricate board repair tonight, sorry. Let's check it. Yeah. Probably something like that, Gary. Or, yeah, Gary. So let's go over the components real quick. This should still be fine. This should be fine. So this is the RS485. This is one of the LDOs. This is actually the initial LDO that turns on. This is the MOSFET. Here's some, I think these are the caps for the timer. Not 100% sure. I mean, this looks horrible, but that's fine. Yeah, this is the timer itself. Yeah, okay. That's nothing. The little LEDs. Yeah, nothing looks outright dead, but the cap... Wait, these caps look bad to you? They look pretty good to me. Sure, I can test them. Where's my multimeter? First, let's check if there's remaining voltage on there. I don't think so, but... No. Hold on. Let's just check this one. Yeah, this one has some slight voltage remaining, but that's the only cap that's directly connected. And there's no drain on there, so... Is data in the wrong terminal? No. Data is over here. Right, so... And I'm quite sure this is VCC, because the fuse is coming from here, so, yeah. Let's check this capacitor. Nope. Some voltage in this one, but those are for the LDOs, that's okay. Let's check this. Oh man. So I'm not sure the on-screen capacity measuring will work. $18 UF? No way. Yeah, so for some reason... Oh, there. PC software also does it. Okay. No way that's an 18 UF cap. That is a 2.2 UF cap. So measuring in circuit doesn't always work. Yeah, this also isn't a 4... Nope. Can I measure this one? Yeah, no. It really has no clue in capacitance measuring. Does it measure this one? Not like that. Oh, that's actually pretty close. Okay. Well, I have the thermal camera, so we'll take a look if anything heats up, but I don't think so. I think stuff just died. So, okay, let's measure the delay caps over here. Yeah. I don't think we'll be able to measure those. these. $18, okay. Yeah, the measuring caps in a circuit is kind of, you know. Oh. I guess that could be correct. Let's see over here. Oh, wait. One reason might be because I'm measuring on a metal base. Okay, yeah, that's fairly correct because the big output capacitor is on here. So it should measure the same over here. Yeah, we can check on another board. So let's see what this guy says. Oh, sorry. Yeah, it just says nothing, which makes no sense. Okay, yeah, it is 2.2 UF, so okay, that measured correctly. Sorry you can't see this one over here, but these are from the timer circuit, and that should be about 4.4, I believe. Let's give it a minute. Okay, let's try it again. I don't know. Okay, yeah. So there's 2 times 2.2 UF there, and they're measuring as 4.62. That is close enough, I'd say. So let's measure it on the dead board. Come on. Yeah, okay. If we measure it on the dead board, we get almost nothing. And if we measure it on a new board, we get 4.6 UF. Okay. So on this new board, it works. And on this old board, they are likely shorted. So let's do a continuity test. Exit remote mode. Okay. Oh yeah, that's bad. Oh well, let's check the working one. Yeah, okay. Something is definitely shorted. If we check the one of the fresh boards, and we measure this cap here, nothing happens. Or this one here, nothing happens. This one here, nothing happens. Okay. Let's try it on the broken board. That is definitely shorted. Shorted. Okay, these aren't shorted. Okay. Good. Let's check the input cap for the LDO. Okay, that's good too. Let's check the input caps for the other LDOs. Oh yeah. Should be fine. It's fine. bad, bad. Get the flux out. Could be the transistor in the 5 shorting the caps. Yeah, possibly. This is a Siglent SDM3045X, and it's a 4.5 digit, and it has a LAN connector, to which I then use the PC software, and I used a very clunky screen capture method to then overlay it in OBS. It works okay. It's not great, but it works okay. Check the 0.10. Okay. I'm wondering what to do here. I can replace those caps. Okay, let's try and replace those caps. I don't want to do too much soldering tonight, but we can try and replace those caps. Let me check what the largest 1206 cap is that I have. Oh, 10 volts. I'm trying to think about which circuit is feeding this, and if 5 volt. Yeah, that's a good one, Matteo. I think this should be a 5 volt circuit. I'm not 100% certain though, but I think so. I think I'll do that with hot air. I can try and do it under the microscope, but let me check. Problem, this is machine soldered. So let me try and make that. So this needs to go hot. So let's do 450 with an airspeed of 100. Okay. Okay. But I need to heat this whole board up. I wasn't oriented great to do that, but I don't think I disturbed anything else. Maybe this little diode here, but it'll work. Which one are we talking about? You mean this here? The MOSFET? Ow, 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 okay. Ow. Don't put your fingers on the caps you just took off. No, that's not shorted. And I measured those caps and ow. But yeah, that should be fine. So we need to give it a little bit to cool down because that was hot. Ow, burnt my finger. I put my thumb on the caps I took off. Okay. So, continuity test. Let's measure here. Aww. So that didn't fix it. Oh, this little diode here got nudged. Oh, that's what you meant with few. Wait, this diode is also bridged? Maybe, let me check the other way around. What? How is this diode bridged? Yeah, I didn't orient the board easy enough. Yeah, but it should only short circuit one way, right? Let's test this diode. So this way we have a pretty high resistance. And this way, yeah, it doesn't do anything. And this way, okay. Let me check the circuit real quick. I don't think that diode's supposed to be short-circuited. Oh wait, no. Okay, now that's fine. Sorry. Wait, is it fine? Wait. Where's my timer? Hold on, please. This one. Okay, so my timer capacitor is this one. So the timer capacitor is actually still fine. And these other two capacitors are for my what are they for? I'm thinking I don't actually need those. No, it is, because it's a Zener. It's a Zener because it takes in 48 volts. So you don't want to put 48 volts on the gate of the MOSFET. So it's a Zener diode to lower the voltage on the gate. So let's see what voltage it makes of this. Oh, wait. Yes, but it should be, because it's a Zener. So these are actually all on the output of the 5F5. So if you look here, we have our 5F5 timer. It goes through here. This is the timer capacitor. It goes to here. It outputs this N channel, which then goes here. It basically lowers the voltage for the gate for this P channel. Right? Because you can't put 48 volts on the P channel, because then it'll blow up. So in that sense, it's logical that these... is it logical that they're shorted together? Only when the N channel would be activated. Yeah, the FET got really warm. The resistor there basically functions as a limiting resistor. We can test if that resistor still works. Two-wire resistance. Well, no. It shouldn't be 21 ohm. Let me measure over here. 21 ohm, okay. Well, try a random other resistor. Yeah, 5.1K, that's correct. Wait, I can't see if you guys can see. Hold on. Yeah, okay. Let's check this resistor. Okay. Yeah, I can remove the zener. Let me try and measure one over here real quick. Let me check something. Okay, so this one. Okay, and that's 1 mega ohm, that's correct too. No, I don't think there's a scorch mark, or maybe we created it ourselves. That's just shadow. So let me check capacitance on that timing one again. Once again, capacitance. Checking capacitance. Okay, yeah, 2.7 UF. It should be 2.2, but that's fine. Of this resistor right here on a new board. Okay, let me check. Wait. We were looking at it this way. Otherwise it gets confusing. 2-wire resistance, where are you? Ah. So 146 kilo ohm. But this one should be a mega ohm. Yep. Okay. And on the broken board, this one should be a mega ohm. Yeah, close enough. And this one. So this one's 20 ohm here. Well, on this one it's some 100 something kilo ohm. And what should it be? What should it be? So I have to juggle a lot of screens here. It should be 200 kilo ohm. Yeah, it's interesting. This indeed should be much higher resistance. Well. No, okay, this is a good board, sorry. Yeah, so that resistance is very different. We can measure resistance from here to here, I guess. Okay, that's almost nothing. Well... Nope, sorry. Well, on here... Yeah, so on a good board, if we measure from the source to the drain, we see 350 kilo ohm resistance. And on this one we see almost no resistance, so that's a short. No, but the components that aren't there are not of influence for this circuit. Fit gone to heaven? Probably. So if we check continuity, then likely the source is shorted with the drain. Yeah, source is shorted with the drain on the bad one. And on the good one, source is not shorted with the drain. So that is likely a dead MOSFET. Yeah, if the MOSFET is shorted open, which it is, there will be no delay because, well, it's open anyway. Or closed, I guess you should say, but... Yeah, so we can remove the MOSFET, but the problem is I don't have one of these. I don't think I have one of these in stock. They're on the way, but they're not here yet. So we can do a transplant, or we can try a transplant because it's tricky. Okay, let's try that. We don't actually need these capacitors, so we can dump those. That's fine. Right, so let's try and get a good MOSFET off of this board. I'm going to try and be really careful here. Okay. Yeah, I think because it flippered so much, that's also what killed components on the other boards. I think that's what likely killed it. But, you know, that problem likely just isn't solved yet. Okay. I don't think I turned it, so that's good. Let's get this one off. Okay, let's get the good one on there. Yeah, no. Okay, wait. Ah. Okay, I need to add some flux because it's way too close together. It doesn't need a lot of current because it's just limiting a gate. So let me add some flux here. Yeah, the terminal's going to be a bit toasty, but that's okay. Now the flux will probably be gone before the board's warm. Uh-oh. Okay. It's flipped. Now I need to look at the correct orientation. Damn it. Okay. Okay, now it's gone. Ah! It's flipped again. Where the hell did it go? It's amazing where these things can jump. Nope. Escape successful, yes. I have no idea. Oh, wait. It's on my pants. Okay, I got it. It's here. Oh, damn it. Okay. Let's hope I have a good grip on it now. Flux is all gone, but okay. I might need to lower my airspeed a bit. That should do. Ah, board smoking. It's bad for your health. Well, there's no short. Ow, tweezers are hot. Yep, tweezers are still hot. Is that soldered on or not? I'd say that's making contact. I'd say that's making contact. I'll take it. I'll take it. So, the question is, do we still have a short? Of course, this board is 6 million degrees. No short. Right? So if we now measure from here to here, we get about 400 ohms instead of like 20 ohms. Or open even. Yeah, instead of, you know, dead short. Good. Instead of, oh, we got 0.1 before. Okay, let's let it cool down a little bit. 20 ohm resistor. Oh wait, I'm doing things wrong. This needs to go in here. Okay. Let me check the resistor. Hold on. But the problem is, this isn't going to solve my problem. Right? So, once it works, we're going to try something else. Sorry. Finally can talk again. Nice. Nice. Okay. Let's see here. Are we in... No, we're in continuity mode. Okay. Yeah, we're now getting 50 kilo ohms. And it should be... It should be 200. So I'm not sure why we're getting 50, but... No, we don't need the capacitors, actually. I think I'll leave them off. Oh, we're getting about 2... Oh, damn it. No, we're getting about 50. I'm not sure why. Let's turn the probes around. Okay, so this way around we are getting 200 kilo ohms, so that's good. It's probably because of the Zener, it only conducts one way, so... those aren't a necessary part of the circuit in that sense. I think I did it to stabilize the gate, but I want to try without it. What I actually want to try is, I want to try it once to see if it boots up and the delay is back. Oh, still hot. And then if the delay is back, we're going to replace another capacitor. Still hot, still hot. Ow. Okay, bad. Why doesn't this click anymore? What? Okay, there. So we're going to turn this on once, and if the delay is back, we're going to replace this big capacitor here for a much bigger one, and then see if the delay gets a lot slower. I hope so. So let's set I set to 1. Yeah, well, we might still need to solve the 5 volt on the day line, but that's a separate problem, I think. So let's see. Okay. Right? Okay, the delay is working. So our 555 timer chip is back to life, or at least it didn't die. So let's go back to the microscope. And we're going to try and replace... I need to orient it so that I can replace it. Hold on. We're going to try and replace this guy. Okay. Yeah, exactly. They are for smoothing the opening of the gate, but it's not really needed, so I'd rather leave them off for now. I'm gonna try and make it so you guys can see, but okay. So that is a 2.2 UF capacitor. I'm going to replace that with a 47 UF. And in theory, that should make the delay so much longer. I don't even know how long, but we'll see. What? It jumped on the board. Okay. Yes, smelled burnt plastic everywhere. Well, that's what you get for being a prototype. Sorry. Okay. I'm going to try and do this without flux. So let's heat up the board first. Ow. Okay. That really melted that connector. Oh no, it's not in place. Oh no. Oh no, hold on. Nope, still not. There. I'm not sure why this is a 1206, right? Oh! I was like, why doesn't this stupid capacitor fit? But it's a 1206 pad, but I had a 0805 capacitor. Oh well. Well, is it making contact? I think so. Let's do a capacitance check on the pads. Capacitance. It technically fits, exactly. It's smaller, it's not bigger. So let's see if I just touch the pads. I don't want to melt this connector even more because it's already melting on that capacitor there. So let's measure it directly. Nope, hold on, other way around. Okay, on the capacitor. Okay, on the capacitor I can measure it like this. Can I measure it like this? Yes. So on this pad? Yes. But if I do it like this? Okay, so this pad isn't connected. Okay, I'll get a 1206. I'll get a 1206. Jesus. I have one that big. 10. Yeah, this is a 805. Damn it. Okay, we got a 22. We got a 100, but that's a bit much. Okay, we'll go for a 22. Yeah, but it's hard to get my soldering iron in there, and I need to flux it up again, and I'm just gonna get a 22. And there was a 2.2 there originally, or 4.7. No, I don't remember. But 22 is a magnitude higher than that was there before. Okay. Okay, let's burn some more connector. Let me see how I can orient that the best for myself. Like this, actually. Yes. That is hot. Oh no, it blew off. Oh no. Let's make sure those pads connected again. Because I touched the RS485 chip. It was a kind of a shit show. But then I think I salvaged it. No, I have it on 450 degrees. Maybe I should put it on like 400. Or at least a bit lower, and lower airspeed too. There. Yeah, the plastic dipped cap. For sure. But that's the problem with these prefabricated boards. They use very high temperature paste, so... And there's all kind of ground planes in there and stuff, so your only chance is to heat it up real quick, because if you wait for the long game in heating it up, it'll take a while. So let's measure this cap now. Maybe I prematurely killed it. Come on. It can't be 51 NF multimeter. Okay. Yeah, well, I'll take 28. That's fine. It's a 22, but, you know, more is better. Okay, so this board has been mangled, so that goes on the mangled pile. Ow, still hot. Yep. Verified, board is hot. Man's not hot. So, let's, oh, okay. Wait. Can I touch this? Yes, no. Ow! Okay, it's time for a drink. It's time for a drink. There. Oh, much better. So now that my body has acquired new liquids, I'd say a hot tweezer is worth it if you have to do that a lot. Same thing with a desoldering gun. I have one, but I use it so irregularly that it's not on my desk, and then it's often just too much of a hassle to take it out. So, unless you have to do that daily or like multiple times a week, I'm not sure it'll be worth it with tweezers or hot tweezers. So I don't know. Let's face the heat, and why does this not click? There, click. Okay. So in theory, we went from a 2.2 UF to a 22 UF capacitor now. I need to double check something real quick. Yeah, it's in a 5 volt circuit because this is only a 10 volt cap, but that should be. Hold on, should be fine. So in theory, our turn on time should be 10 times as long. Maybe? We'll see. 3, 2, 1. Is it gonna turn on at some point? Oh, well. Oh, that's certainly a lot longer. Look at the. Okay, off. On. Nice. Okay, so let's time it. Let's time it. Hold on. So let's give it. Okay. 1, 2, 3, 4, 5. Oh, okay. 5 seconds. Let's do it again. 1, 2, 3, 4, 5. Perfect. So it should have been 500 milliseconds before. It probably was. This is a nice delay. Yeah, exactly, Monty. So hopefully that prevents that stupid flickering too. Because, well, I don't know. Maybe. That also means the 555 is still soldered on correctly, because otherwise that wouldn't work. Now let's try and plugging it, but I'm going to plug this side. No, I'm going to plug this side. Yeah, I'm going to plug this side. So it's disconnected now. And I'm plugging it in now. Why does it turn on instantly? That makes no sense. Let me try that again. Why? Why? How? Yeah, but if it's stored charge... Okay, let's disconnect it for a longer while. I can take more drink. And it's not a stored charge on the 555. It can't be. Because then it wouldn't do it at all, right? I mean... There is one extra resistor we could solder for some extra drainage. But let's check the voltage on some capacitors here. No volts. Almost no volts. Almost no volts. Almost nothing. Almost nothing. Well, 5 seconds right now is correct. That is in line with what I would expect with the larger capacitor. Nothing here. Oh wait, other way around. Yeah, I'm not measuring any big voltages. Maybe on this cap here. No, wait, this cap isn't even in the circuit. Yeah, but how? Where is it getting the power? Because that circuit is not connected. No, it shouldn't. We're trying to build in a delay. That's basically what we're trying to do, Iman. So... The gate is left open. Let me measure. There is some voltage on the gate. Oh, wait, but it's a P channel. In theory, my N channel should have a pull down. It does. And my P channel is off until it gets negative voltage. Yeah, there's a pull down on the N channel. So that turns off the N channel. And there's a pull up on the P channel. So that should turn off the P channel instead, unless... Well, we might need to remove a diode. Okay. We might need to remove a diode here. Yeah, I'm pretty sure the cable's fine. We're gonna try it again. We let it alone for a while, and if it instantly turns on again, we're gonna remove one of the diodes. Okay, so let's try it again. Yeah, okay, still did it. Okay. So which diode should we remove? Let me check this one. Okay, and we're going to be removing this diode right here. Or that resistor, but the diode's easier. So that diode's on there to act as a bleeding channel. But I'm now wondering if before power is applied... What the... Did I get flux in here or something? Maybe. I'm wondering if now before power is applied, it actually activates... it actually activates it. So let me double check here. Yes. Okay. So this diode needs to go. It's again an extra part of the circuit. Okay. Sorry. I need to make sure I can reach it good. Reach it good, yes. The perfect English. Well, that's what I'm thinking. This diode might actually be allowing a pull down before the pull up activates. So we're gonna whip that off and see what happens. Alright, I lowered my temperature and airspeed. Okay. Later, Emil Bart. Thanks for hanging out. Let's see, how can I get it off of here? Okay. No, no, I just put it off completely. Don't worry, it's just a little diode. So that was part of a circuit that should allow for some parts of the board to bleed when there was nothing connected anymore. But now I'm wondering if that might be causing other issues. Yeah, that might actually be good. And this was always designed with extra bits and pieces in the circuit. Because, you know, you can design it in there and just not put it in there. But if you don't design it in there, you can't put it in there anymore. So I'd rather have too much stuff in there and then remove it for testing and change values and things like that, instead of not being flexible with the prototypes I have. Okay, with some manual cooling, still sits badly. Does this side work better? No. Not sure why this is so horrible, but okay. Right, so let's try a normal power up, see if that still works. I think so. So, normal power up. Yep, okay, still works. Good. And now let's unplug it. Okay. And let's replug it. No, still does it. Well, there's another extra diode on there, I think. Let me check. Yes. Let me put the board in the same orientation here. Okay. I don't understand what is happening in regards to why is this so bad? Okay, it's time for another UTP cable because this is driving me nuts. Does this work better? No. This socket just... Somehow I ruined the socket. Okay. So it's working, but then it's not working. Let's check the multimeter if there's actually any voltage going on somewhere. DC voltage, yes. So is this part getting any volts? It should be right now. Yes. So let's turn the power off. Okay, drains pretty quickly. So this is the output from the MOSFET. So this should take 5 seconds to turn on. So let's turn on power. Okay, no output to the MOSFET, no output to the MOSFET, no output to the MOSFET. And there it goes. So that works correctly now. But does it also work correctly when plugging? Let's try it this way. Okay, we have measurement. Well, somewhat. Hold on. Can't see the lights there. No measurement. Screw them in softly. So now let's unplug the UTP cable. Okay, so there's no power. Fine. Oh, don't focus on my hand. There. Now plugging it back in. Did it see power or not? So unplugged UTP cable, plugged in. It sees power for a fraction of a second and then it's gone. But that's exactly what I'm trying to prevent. So no power. Plugging it in. Okay, I need to set the multimeter to very fast. Fast. Okay, we're in multimeter fast mode now. Let's go to okay, hold on. I have a trend graph, so yeah, it really sees a little power spike. I have no idea why. Well, it's likely a 55 volt inrush, but it's too fast because it's gone too quickly. Hey Rob, welcome. You missed a little bit. We're still trying to figure it out. If I turn off the power supply, hold on, and turn it on, we get a nice power on delay over here. There. Then it's fine. Then it sees no power. So what would cause... What's the difference? What is the difference between plugging in the cable or turning the power on and off? I mean, isn't it the same thing? Except you're disconnecting the ground loop, that's true. I mean, we mentioned that earlier. That is true, but I mean... Remaining ground, yeah, sure, sure. Now, the data signaling doesn't have anything to do with the power circuit. So maybe I need a bleeder on the gate. And even still, I don't understand, because the delay circuit, I don't know, but something has remaining residual power. So, okay. Let me check something real quick. Okay, there's a Zener. If you pull the power on the upstream component, So you're just unscrewing it, you mean? We can carefully try. So if I unscrew this one, you mean? Need to be careful because there's a mounting hole there. Okay, so now it's off. Yeah. I didn't check it. Hold on. Yeah, it does the same thing. See that? Ground is never gone. So it's not ground. Yeah, but no. That's exactly what I just did. I pulled the positive from the center board, but I left the ground connected. So everything was still grounded, power supply was still on. But then again, a P channel needs ground to turn on. It needs positive to turn off. So let's disconnect negative, but keep positive connected. Now we need to be really careful. Okay, so ground is now disconnected. There. Okay. Let's do it one more time. Yeah, no, okay. That doesn't do it. And hot plugging 55 volt makes a nice tick. Okay, so hot plugging positive or negative has the same behavior. But turning the power supply off and on again, even quickly, let's try that again. Yeah, even quickly, it works fine. Huh? I don't understand. Yeah, let me try and hold my meter here on the gate. Although I doubt I can measure the gate. Wait, there's 55 volt on the gate? That can't be right. Yeah, there's 50... Oh, that is right, sorry. Ah, man, P channels always trip me up. Okay, there's 55 volt on the gate. So let's turn... 44. Let's turn off power. Power on the gate is gone. Turn on power. Wait, why is it back? No, okay, oh, sorry, that's correct. Ah, so, but that is the problem, isn't it? So, you need a 10 volt minus different on the gate versus your source voltage for it to turn on. Because you don't want it to be too much, because then you blow up the gate. That's why the Zener is there, blah, blah, blah.
There goes nothing.
So it jumps to 53, that's fine. And then it goes to 44. So if you turn on and off the power supply, it works. How do I the hell plug this? Okay, it's off. And now I'm plugging in the UTP cable. It does the same thing. What? What? Okay, let's try that again. It's not the gate of the MOSFET. So, unplugged. Oh, okay. Unplugged. Gate of the MOSFET's very low. Plugged in. The gate of the MOSFET is the good voltage, so it's off. And then it turns on. So, okay. It's not the MOSFET.
I'm lost in old ways.
Okay, so let me show again. This is, we're measuring the gate of the P channel. And I plug it in now. It jumps to 55, that's good. So it's off. And then it goes to 44, so it turns on. That's perfect. But then if we measure the output, we have a sudden burst. Okay. No, it's not. When it's off, it's off. Yes, there is a resistor in line to the gate. From the 555 timer. Because the 555 goes to resistor, pull down, N channel, and the N channel, again resistor, to the P channel gate. And there is the zener in there to make it a 10 volt difference instead of 55, because then your gate will blow up. But on the 555 timer side, everything goes correctly. So it might be those three capacitors. No, it's not. Okay, let me check the N channel here. Well, that is supposed to go 0 volts, isn't it? I need to do this in reverse. But then I need 5 volt. Okay. Let's measure where we have 5 volt. Do we have 5 volt here? No. Because otherwise I'm going to blow it up. Do we have 5 volt here? Yes. Okay. Yeah, I don't think I can measure this with one hand. Let's see, where else do I have a good 5 volts? Oh, right, over there. No. Hold on, let me figure out how I'm gonna measure this. This is the input. Zero. Okay. Yay. No, I don't think this is gonna work. Why? Okay. Off. Okay, so if I turn the power supply off and I turn it on again, we see minus 5 volt. That's perfect. Okay, let's unplug the connector, plug the connector in. Same thing. Okay, I think I know what's going on. Okay, so replugging the connector. Minus, 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 minus. 5 volt. Okay, so the 555 timer circuit and the P-channel gate are not the problem. So, if those are not the problem, it has to be residual capacitance past the P-channel gate. Right? Oh, we can do another measurement. Hold on. We can measure continuity. No. Should we do that? I don't know. We might blow stuff up. Oh, well, you know. Continuity. Where is it? We can measure continuity on the MOSFET. So, right now, the board is off. And the continuity is pretty high resistance. So now let's turn the power on. Beep. Okay. So power off. Power on. There's a slight jump there and don't know why, but that's what we're investigating. And then 5 seconds later, resistance is gone because now the MOSFET is open. Right? So let's do the same thing when we plug the connector. So that's fine. Unplug. High resistance. MOSFET, the P-channel MOSFET is closed. Or open, whatever. We plug it in. We wait. And low resistance. So, okay. Unplugged. Plug it in. Nothing happens. We wait. Low resistance. So that verifies that the circuit is doing exactly what it needs to do. So the problem is behind the P-channel MOSFET. And then the only thing that's behind the P-channel MOSFET, let me go to the microscope again, is those 3 capacitors. Because the MOSFET delivers the positive channel, the ground is always there, and the MOSFET just... No, wait. Sorry. Yeah, the ground's always there. The MOSFET delivers the positive 555 volt, and then opens that so that it can go to the buck converter. So the only thing that's left there is these capacitors. Because the circuit, the 555 timer, the N channel, and the P channel is doing it perfectly correctly. No, that's... No. I think there's residual power somehow that remains for very little moment. But it's not measurable. Can't measure anything. Huh. No, I'm not. The caps are fine, I think. Let me see. Capacitance. Yeah, 15 UF, 16 UF. That's fine. Well, I don't know. I guess they're not getting drained fast enough. But maybe I can't measure the voltage because there's no ground. Yes, they are meant as smoothing caps for the buck converter, but the buck converter isn't connected, so... Yeah, that's what I'm thinking. I'm going to take these caps off and then see what changes. Right? Where are we? There. Okay. Then again, hold on. What do you mean a temporary wire? Jesus. Hold on. Okay. No, man. My voice is still not liking me a lot. Okay. That's probably hot. Well, but we tested that, Philip, because we tested with removing just the positive of the sender board. So we tested it with removing the positive here, but keeping the power supply on and keeping all the ground connections in place. So, yeah. Now, the actual question is, how much of a problem is this? Because we're trying to prevent a power surge on the UTP cable and on this connector. But the power surge we're seeing is after the P channel. So, I don't think there's an actual power surge. I think there's residual power that somehow gets activated. Right. Yeah, maybe I need some, I don't know, draining resistor on there. But as I said, the problem is I don't want any peak power on the RJ45 connector. But likely it's just ground being connected. But then again, I guess that's power too. But yeah. Later, Anders. Exactly, just a little bit to power the LED for a second. There, I've blown on it very nicely. So let's see if everything still works. Except this stupid connector. Okay. Okay. Yep. Okay, still good. All these extra components. So now let's remove RJ45 and let's plug it in. It still does it, but it's very quick. But we just verified that the P channel actually stays off, right? So the P channel isn't letting new positive power through from the RJ45. It can't. We measured that. The P channel is off immediately when you start. don't understand. It works so nicely, but at the same time it doesn't. Yeah, maybe. So the 555 timer circuit, the N channel and the P channel, those are all fine. But somehow this stupid LED lights up right when you plug it in. Yeah, I think this middle one just needs a pull down. That is on the buck converter output. But there's no buck converter connected, so... Yeah, exactly, Rob. That's, you know, that's why I'm working on this. I have to try and make it safe. Yeah, it's just instant. Just instant. Remove the LED. Yes, that is the solution. No. Oh, did I melt my RJ40? Oh, I melted my RJ45. That's why it's so hard. Okay. So we need a bleeding resistor, right? So what if we get a 1206 and put it in place of that cap? Because that is after the P channel and the second side is ground. So if we think somehow capacitance lingers, I don't know where, because there's literally nothing connected. I mean, can we measure? We can measure the capacitance, can't we? Capacitance. Is there a capacitance on this circuit while it's off? There is. There is 9.7 UF capacitance on this circuit. Ah, but that is of course for the LDO, and yeah, so on this circuit there is also a input capacitor for the buck converter in LDO, which has an LED connected. Yeah, but that's normal. That's normal. I mean, we're putting power in the circuit to measure the capacitance. So if I put it in diode mode, oh wait, okay. Let's try this. Yeah, okay. There's a high resistance. That's good. Yeah, now in capacitance mode, we're injecting voltage, so that's normal. So, there is still 9.05 UF capacitance there. I don't know what that is, because my caps aren't that big. But then if we measure voltage, there is no voltage here. In continuity mode? Yes. Rob has an idea. I think we should put a capacitor here, or a resistor here. Sort of bleeding resistor. A bit of both, Yannick. What? Test the off-the-shelf sender? No, that's not a good idea. Okay, let me see if I have a very high value 1206. Don't know. I might. 15 ohm. That's not. No. 24 ohm. 47 ohm. Why is it going the other way? 2 ohm. I don't think I have any high value 1206s. Because then I'd use a lower, a smaller capacitor basically. Or a smaller resistor. Do I have a 1206 book? I might. Let me check. Sample book. These are not 1206. 805. Nope. Nope. Okay, let's try an 0805. I might be able to jank that in there. So, somebody needs to calculate current. What kind of value do we want? No, we can create a little bit of short circuit there. That's no problem. It'll just, you know, get warm. Let's go with a 330K. I mean, that's not a lot of power. It's 55 volt though, but I mean... $330K 0805. Okay, my closet is a ruin. Let's see here. Okay, let's go to the Microscope. Whoa, this puny 1 mega ohm. No. We're gonna go 330K. So I'll just I'll manually solder it on both sides. Hold on. There we go. So let me tin this pad. Okay, that's tinned. Now where did I leave it? Oh, there. Okay, that side's on. What do you think? Oh, you can't see. Where is it? Oh, there. That sucker is on there. No problem. 0.1 milliamp. Yes, good. That's fine. We can deal with a 0.1 milliamp of constant drain. Looks like my SMD work. Well, you know, better too much solder than too little. Well, that's actually not true. If it's short-circuiting, that's not true. Okay. So now the board isn't hot, so we can immediately test it. Okay, power supply's off. So let's plug this in. Okay. So, oh wait. Let's remove the solder wire. Creative architecture, yes. Okay, power on. Perfect delay. Everything great. Okay. Now let's disconnect this. But then how long do we wait? I don't know, I'm going to connect it. It still did it! Why? Why is this happening? Okay, we waited. Okay, let's wait a while. This is, I believe, is a Shamsi. You can buy them on AliExpress. It says it's Cat 6A, but then it has really thin conductors. Let's wait for a little bit. Well, I could measure the temperature, but this isn't... Yeah, that little resistor isn't getting very warm. And I mean, is it even doing anything? Because it's draining to ground, but there is no ground. So, I mean, then what's it going to do? Let me check if I made... I don't think I made the screw holes ground. No. Screw holes are not ground. Okay, so we're going to try what Philip suggested hours ago. Let's see if I have a wire here somewhere. Oh, I have a wire here. But if that works, this is unfixable. Okay. So we're going to screw this into the ground terminal here. A flyback diode. Oh. Yeah, some G. I think I have the back here. Sorry. I believe they're these. The blue one is from them for sure. But it's in some kind of Queen box many years ago. Okay, so let's not connect it yet. Let's try it, see if it did anything. Nope, still the same problem. Okay. So now let's touch ground. I'm touching ground. Feel like a pervert. Touching ground here. Okay. So now we had it drained to ground for a little bit. And now let's try it again. Still does it. What do you mean? Why? How does that even work? Oh, I can connect it to the ground on the dig quad. Yes. Oh, this is not the squished one. There. Okay, so now it's permanently grounded. So let's plug it in. Still does it. How do you mean does it recover? Yeah, the circuit works. The circuit is fine. If we measure voltage, DC voltage. Yeah, Still getting 55 voltish. Ooh. And let's turn the power off. Turn the power on. No problem. Everything works great as designed. As it should. Perfectamundo. Power off. Power on. No power. No power. No power. Power. Perfect. Unplug. No power. Drains all nicely. Good. Power. Suddenly, temporary power. I mean, you can see even the voltage draining there. So there is the draining, the bleeding resistor is working because there's basically almost no voltage left. Let's wait. Okay, so this basically it's fully drained. There's a short spike there. No clue why. Okay, let's try something else. Let's connect the buck converter and see if having the buck converter connected actually prevents the issue. Still a stupid issue. But I mean, then there's a load. There's already a load on there because there's an LDO and capacitors and an LED and things like that. Hey, it's Johnny Burgle. Are you back from the bars? Did we stream long enough for you to be back? You think the charge is left in the MOSFET? That's a new to me. Okay, so now we have the buck converter connected. So let's see if it still works. Yeah, that's what we're trying to do, Matteo. So now let's turn on the power. Okay, nothing. Beam. Okay, good. Turn off the power. Well, now it drains slower because, you know, the capacitor in the buck converter. Yeah, I probably also need to slow down the gate even more, but we'll have to see about that. Okay, so now let's try disconnecting the cable. So cable is disconnected. Of course it drains slower now, that's fine. Oh. What? Now it stays on? Uh-oh, did we already kill it? Oh shit, I think we might have killed something already. Damn it! We probably killed whatever we killed before. Oh, did we kill the MOSFET? I think we killed the MOSFET. Again. Let's plug it in. Yeah. So, power off. Power on. Yeah, okay, the MOSFET's dead. Okay. Okay. Let's test it to be sure, but I'm pretty sure the MOSFET's dead. Continuity. From here. to here. Yes. MOSFET dead. Okay. This circuit needs some rethinking. But why does it kill the MOSFET? I mean, we verified. Sorry, Monty. It's a 60 volt MOSFET. But I guess it can't stand hot plugging 60 volt? I don't know. Let me try and measure here. Oh.
Remember all the happy times we had?
Should be able to measure something here.
Very much alike.
Maybe not. Yeah, this still works okay. Spikes might be higher, that's true.
Remember all the happy times we had?
Thanks for being here, Clint. Yeah, but the problem with the voltage mostly is on the gate side, I'd say. But there, the Zener should be taking care of that. And then we have the source side. But the source side isn't drawing any power because the MOSFET is off when it's plugged in. So I get what you're saying, Rob. But I mean, in theory, it's not drawing any power. So let's see, if I turn it on, the Zener should be, well, the Zener should be minus 10. So I need 55 and this side. Yeah, the I didn't get a good connection. Yeah, the Zener is still minus 10. Damn it. I'm having a hard time measuring it. Hold on. No, okay. Why can't I measure this? Not sure why it's flickering that much. I don't know. Then again, this is a blown gate, so I mean, let me measure from here to here. What? What's going on? Hold on. Yeah, so this time we might have also blown the Zener. I believe the Zener is rated for 100 volt. Yeah, because we're measuring zero difference between the source and the gate. But that could also be because the MOSFET's dead.
I'm walking slowly towards you. I want a tour of your world and what we can do. But I'm a little
What? Johnny tried to buy a house today, but he failed because to get a loan because the seller was in debt. Doesn't that just make the house cheaper? Or more expensive? Wait, what? I don't know. What does that have to do with the house? Let him sell the house, then he can get out of his debt.
slowly towards you. I want a tour of your world and what we can do. But I'm a little overwhelmed.
Yeah, I'm not quite sure what's going on right now.
It feels so good.
That's measuring continuity. Maybe just everything is connected together. Probably. So let's see. We have this guy, which should be on the gate. Yeah. Okay. The Zener diode is also connected with source. Well, I guess it would be on that side. On one side. Okay, the Zener diode is connected to source on both sides. That is not right.
Light up my world, but what if this still falls through? I let you in, our world begins.
I haven't used varistors much.
I'll be heartbroken if heaven's kind and you are mine. I like the rest, we fall forever, but we'll never know until we know. We got this feeling in our hearts, we're healing from a little love, from a little love. This could be heaven if I just let you in for a little love, for a little love. Slowly towards you.
Well, this requires some extra thought. Clearly, this is not the solution. Connect the red and black wires, yeah. Yeah, I'll need to think about what I can do to change this circuit. If you have any suggestions, come to the Discord server. We can always discuss it. But this isn't good enough. Because it worked kind of as I intended. I mean, it worked perfectly. And then, for some reason, when you hot plug it, which is what I designed it for, it doesn't do jack shit. And there's all kinds of spikes, and it still dies. Yep. Well, that will require a bit more thought. But we're not going to do that in this live stream. So, do we still need a secret? Yeah, but then still I need a delay. So you mean a current sensor before the delay circuit? This is SAW. The effect behind me is SAW. But then what needs to be current limited? Because basically everything is cut off until the P channel opens. Oh. I'm trying to understand here, Rob. So that would potentially save the P channel from the spike, you mean, or? No, we measured it. It does not open. Or maybe it does for a millisecond and we just can't measure it. I have to scope it out. At least the gate isn't conducting when we plug it in. I'll scope that out, but pretty certain of that. Yeah, I'll need to think about how to do that. What's best? Because I kind of figured the MOSFET, when it's not allowing power through, doesn't mind being hot plugged. Because although it's connected to the 55 volt coming in, there's no current there. So there shouldn't be anything happening. And the only current is going to a tiny, tiny capacitor that turns on an LDO that then turns on the 555, that then 5 seconds later turns on the MOSFET. But seemingly that's not enough. Yep, okay. Well, this needs redesign. Okay, well, we do need to end the live stream at some point. It's almost 1 o'clock here. If you want to discuss further, come to the Discord server. I'm not sure it'll be tonight, but at some point, you know. I want to thank everyone for hanging around. This was a new circuit we were going to test. And although it did perfectly what it should do, it also didn't do what it should do. The gate needs to be charged too, Rob. And there was an RC circuit on there. We removed that. But yeah. PCB design, I guess, would be the best channel for that. No, we can still do a secret. We can do a secret. Hold on. So, one of the secrets is another thing that didn't work. If we take a look here, we have a prototype. No, this way around. A prototype of a AN Mini, or a AN Penta Mini, right? So a 5-channel analog board with a ESP32C3 on there, etc., etc. And I wanted to use these nice PTCs on here, but I'm starting to regret PTCs at this moment, because this was a pre-production board. Made some changes and, tested things and stuff like that. And then we made a production version. So this is the production version, but I need to get a different one. I don't have one. Well, okay, we can take a look at this one. So we made a production version. And I made a slight mistake, but so we have the case. We have nice yellow input terminals for ground. And plus, we have a nice PCB as front and end. We have USB-C, we have the antenna, we have a few button inputs, etc. All pluggable connectors. And then on the back, we have all color-coded terminals. That took some doing. So we have yellow for power in or out, which is combined. Then we have green for GPIO and ground and 3.3 volts, stuff like that. And then we have red for positive outputs and black for negative or PWM dimmed outputs, and then we have a stemma QT connector in which you can plug in, little I2C boards like. Hold on, I would have to fill with this. It's like USB. You don't know which way is up. You can plug it in like this, and you can easily add some extension boards like from Adafruit or other vendors that make Stemma QT or Quick boards, right? So it's a nice little analog dimmer, and it works great until it doesn't. And the problem is, I went from these through-hole PTCs, which worked great in all the prototypes, to SMD PTCs. Now, since this board is 48 volt compatible, I had to find 60 volt compatible PTCs, blah, blah, blah. Did all that. And it works, except it doesn't. The problem is that these, especially when the case is closed, overheat. So if they do their rated or close to their rated output, oh, Niagara, ask on the Discord server. We should be able to help you out. But yeah, especially with the case closed, these are overheat because of the resistance, even if they're working correctly, basically. What do you mean, zero documentation there, Niagara? There's a whole section on the website dedicated to it. Anyway, so yeah, I need to devise a fix for this because I already produced these boards, but this is not working correctly. But I think I have a fix, and I'll be able to test that next week, I think. And then I'm hoping we'll be able. Oh, no troubleshooting, guys. Okay. Well, we haven't had any issues yet, so come to the Discord and we'll discuss what's going on and try and fix it, and then it'd be good to add. Well, no, a heatsink wouldn't make sense. A heatsink on a MOSFET would be fine, but a heatsink on a PTC, which uses heat to close, well, then you'd be influencing the can't speak English anymore. Characteristics, whatever, of the PTC. So it wouldn't do anymore what it should do, right? So I don't think the PTCs are viable in a closed case with this amount of current. Maybe, the through hole, when they can breathe a little bit, and they also get a lot less hot because they have a lot less resistance than the SMD versions, which then bleed into the boards and influences the other PTCs and blah, 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 blah. So I'm going to move to fuses again, and I might even consider moving these boards back to fuses again too, because although on this board you can have it folded down like that, and that should give it enough space to breathe, even if you use it close to 5 amps. Because these have a lot lower resistance than the board versions. I don't know. I'm just not too sure. So I've devised a new fuse solution, because I need a fuse solution that'll do up to 48 volts. And I'm going to test that next week. And hopefully I can retrofit these boards, because I made a few hundred. And then we'll finally be able to release the AN Penta Mini. And we'll have a very nice... enclosed little board. So this is also one of my first experiments with a case next to the Dig2Go. Yeah, and it'll come with all the color-coded pluggable terminals. Of course, all with a plus screw head, etc., Phillips head. So yeah, that'll be a very nice little board to use as an analog dimmer. But yeah. Problems. That's why sometimes things take a little bit longer to release than I'd like them to. But, this project's already taken way too long. But we'll get it figured out in the end. And, yeah. So that's the secret. I have the production boards, but I'm not going to release them. That's the secret. But let's hope I can find a fix for the production boards. And I'm not sure I've shown these before. Sorry, I hit the microphone. Not sure I've shown these before, but we can do it real quick. These are the bigger analog boards. Oh, we've shown these because we tested these terminals on stream. I have new candidates for these terminals, and they're ginormous. So this is all staying the same. These will become red instead of orange, but yeah. No. I won't release things before they're right, in my opinion at least, or in my testing. But I've been working on these front and end plates, and they're clearly labeled, etc. This is the hybrid hexa. Name has changed since then. Sure, Rob, that's always interesting. But we can take a look at the ginormous connectors, because we'll be using those. And they're just funny. They're so big that they're just stupid. They're stupid big. Let me find the right ones. Look at these. If you are worried that your wire is not going to fit, your wire is going to fit. No problem whatsoever. So, instead of having this, we'll have this guy internally here. And it's actually not that much bigger. It's almost the same size. And they'll be pluggable. So they'll be like so. They'll be mostly on the inside, so you won't really see it. They'll stick out the same amount as this. And then you get these ginormous pluggable connectors, which snap into place nicely. And you can actually have 2 on a 4-pin connector, like so. That fits perfectly. That's meant to go that way, basically. No shoving it in there. And that will go on this board. And then on the hybrid hexa, we'll have a 2-pin version. Is this the right one? No. No, this is a smaller one. Sorry. Not sure where I put those. Yep, here they are. No, no, they're still for DC. These can take up to, I believe I tested 12 gauge with a ferrule or 10 gauge with a ferrule even. But you can still use 20 gauge too. So, I mean, you shouldn't use 20 gauge, but you can. They're rated for 50 amps, I believe. I'd have to look it up. But it's just for convenience, right? Because if you have like a 500 or 600 watt power supply, it's easier to run two 10 gauge cables than one 6 gauge cable or something like that, right? So I want this one will have 2 times positive and 2 times negative, and the other one will have 1 times negative and 1 times positive. So yeah, because that's less amps. But I just want convenience for hooking it up instead of having to go idiotic cables. And when looking at these pluggable terminals, and we looked around at a lot of places and a lot of vendors, and I tested a lot of things, and these actually came cheaper than some smaller options. And, well, they're just great connectors. I mean, if you can't get your wire in here, I don't know what. And they're actually cheaper than some other alternatives. So, yeah. That's what we're going with for the analog boards. And who knows in the future. But, yeah. I like them. They'll, you know, if when they're in there, they'll take a little bit of fiddling to get out. But yeah, it's doable. They go into the PCB with 3 connection points. So, we're not going to have much voltage drop. Voltage drop? Okay. Yeah, so I thought that'd be fun to share. That's 2 secrets. AN Penta Mini is close, but currently still not viable, broken in the current version, but I'm hoping to get a fix for that, also for the current PCBs. And then I'll rework the other PCBs. That does mean we'll get replaceable fuses again, but I just don't see a way of being able to make it work with PTCs, so auto reset fuses, because there's just too much heat with the amount of currents involved, etc. But you know, sometimes you try stuff, doesn't work, you pivot and you try some other stuff, and in the end we'll get to a good solution that also works. Yeah, you know, you could go XT30 or Anderson connector or whatever else, but those are all connectors non-techie people will not be able to use. So you know, you need like a screw terminal type of connection to make that, you know, work for everyone. I kind of wish we could use barrier style. That's why I experimented with these, but in the end, in the live stream, it was clear that this was not going to be a good solution. So I abandoned that solution, and no barrier style. Then again, everything on this board, I mean, if you look at all the other connectors, are pluggable style connectors, so it's not that much out of line either to also have pluggable power connectors. No, there's a heart. This is my little heart over here. Okay. Okay, guys, I'm gonna, I don't know, watch some TV and let my brain think of a new circuit, but come to the Discord, Rob, and I'd love to hear what you have to say. So, thanks for watching, guys. See you in the next video, live stream, comments, Discord, whatever. Bye-bye.